Why do bridge collapses show a domino effect? Imagine standing in front of a row of dominoes and knocking over the first one. The rest fall one after another, each triggered by the one before. That's very similar to what happens during a bridge collapse. When one part of a bridge fails, it often causes a chain reaction that leads to the entire structure falling apart. Bridges are made up of many interconnected parts like piers, decks, and supports. These parts share the load of the bridge and work together to keep it standing. When one element fails, it can suddenly transfer its load to neighboring parts that might not be built to handle it. This overload causes those parts to fail too, setting off a cascade of collapses. Take a bridge with a concrete pier that cracks because of material fatigue or an impact. The load that the pier was supporting now shifts to the adjacent supports or the deck itself. If those parts are already weakened or not designed to handle extra weight, they can give way as well. This process repeats, making the failure spread across the structure like a wave. Certain bridge designs are more prone to this effect. For example, bridges with voided slabs or post-tension decks can see rapid failure if one critical component fails. Research shows that in box girder bridges with voided slabs, failure at the seating of the bridge abutment can cause a domino effect, especially during earthquakes. The type of deck, the height of piers, and the ground slope all influence how quickly the failure spreads. Once the initial failure begins, gravity and friction help drive the failure wave through the structure. It's similar to how a line of falling dominoes or a snowball rolling downhill gathers speed and causes more damage. From a mechanical point of view, the energy from the initial failure spreads through the structure, weakening nearby elements until they collapse. This failure wave can keep moving until most or all of the bridge is gone unless something stops it. Some modern bridge designs can resist this chain reaction. Steel truss bridges, for example, can sometimes redistribute loads after local damage, preventing total collapse. But when these systems are overwhelmed, the domino effect takes over, leading to a catastrophic failure. Understanding why this domino effect happens helps engineers build safer bridges. They add extra support, strengthen key parts, and improve connections so that if one part fails, the rest can handle the load. This way, they can stop the failure from spreading and prevent a total collapse. In the end, the failure of one element overloads others because all parts are connected and share the load. When one fails, it puts stress on the next, causing a chain reaction. Knowing this helps us design better, more resilient bridges to keep everyone safe.